or based on our formula, we want 1 minus, what's an A dot 1 at 4.05, or 1 minus something like that, and you come up with something like 0.0001. Okay. I'm not sure that I got the right number of 9s in here. The text actually goes into Minitab and says the p-value is equal to 0.00003. So they actually did the calculation. Okay. So if I see things that are wrong with this, most of the time the problem is people take this value instead of doing the 1 minus. Make sure that you look at it, determine which tail it is based on the alternative hypothesis, and then based on that choose the right equation for what you're going to do with the value you pick up out of table 8.1. Okay.
What happens if we didn't put like 0.0001? What happens if we just put like approximately 0? Is that wrong?
That's acceptable. There are some contexts where I would not consider this approximately 0, but most of the contexts that you'll see, this is essentially 0. Yes, I've run into cases where I need values that have at least 6 or 7 zeros out there before I worry about them being too small.
So I'm still understanding what that tells us then. That just tells us that, or disproves the null hypothesis, or
essentially, yes. A very small p-value is strong evidence for the alternative.
Okay.
Okay, so the smaller the p-value, the stronger the evidence for the alternative. This is a very small p-value, means this is strong evidence for the alternative. Based on that, we would then reject the null hypothesis.
Okay. So what is that showing, the p-value that we have there, what is that showing us on the graph then? What?
This is actually the right tail, or the area to the right of 4.05.
Oh, okay.
Formally, that is the probability of seeing anything that is this large or larger if, in fact, the null hypothesis is true.
Okay.
So since that's extremely small, it's extremely unlikely. So you say that the null hypothesis must have been false, and we have to reject that hypothesis. Okay. Other questions?
So you say p equals a percent chance that the null is true?
Not really.
Not really?
This p-value, the smaller the p-value, the stronger the evidence for the alternative. And essentially what that is that's the probability of seeing something like this or farther if in fact the null were true. But just think of it as small p-values are strong evidence for the alternative hypothesis.
And one more question about the z-value. Why did we need the z-value then to calculate? I mean, I know we need z for the table, but what is that z-value actually telling us about the original proportion?
Well, the original proportion, when we get the original proportion, we've got a p hat out here. We have p hat is equal to 0.59. And what you need to do is, you can't just take the 0.59 and look it up in the table. Actually, you could look up 0.59 in the table, it wouldn't be the right values. This 0.59 is for p hat. P hat is centered at 1/2. It has a standard deviation which is the square root of 1/2 times 1 minus 1/2 over the sample size. The table has a center or a mean of 0, not 1/2, and it has a standard deviation of exactly 1. So in order to look it up in the table, I have to convert from what is centered at 1/2 and has something other than known as a standard deviation through this z transformation into something now that is centered at 1 and has the right standard deviation to it.
So a proportion of 0.59 has a z-value then of the 4.05. Is that what?
In this context, yes.
Okay.
So a proportion of 0.59, when I'm looking at the p0 being 1/2, has a z-value of 4.05.
And that's just pretty much just the p-value centered at 0. Am I not interpreting that right?
Think of this 0 here as actually the null hypothesis.
The Z value like standardizes it so you can compare.
The Z value standardizes it so that you can look it up in table 8.1.
Okay.
And that is the only purpose for it.
Okay.
If we didn't have to use table 8.1, for example, if you use a TI calculator, I could plug in 0.59 and the appropriate standard error from this. So I can plug in 1/2. I can plug in the standard error or standard deviation based on 1/2. I can then plug in 0.59 and get probability without table 8.1. But internally in the calculator, it does this. So when you give it the 1/2 and you give it everything else, it's going to do this calculation. And essentially in the calculator, it will look up 4.05 in the tables. And in fact, that's what was done here. Minitab did that for them rather than the calculator. And it comes up with an accurate p-value. Okay. So the Z is there to translate from the observation of 0.59 to an observation that is one that we can look up in the table. Okay. Other questions? Good. It's good discussion. Let's see, what was that, step 4? I calculated the p-value. It says on the basis of the p-value, make a conclusion for the situation. Write it in both statistical language and in words that someone with no training in statistics could understand. So in this case, what would our decision be? We're going to reject the null hypothesis, so that's statistical terminology. In this case, the statement that we make here is that we have evidence here to show that, in fact, a majority of individuals favor allowing women to be priests. Okay? So we essentially translate this alternative hypothesis back into the original context of the problem and make our statement in that context. Okay? The last part of this, one, the confidence interval. 95% confidence interval. That is p hat plus or minus z star times p hat 1 minus p hat over m. So plugging our numbers in, it's equal to 0.59 plus or minus 1.96 and the square root of 0.59, 1 minus 0.59 divided by 507. Now note here, when I use the standard error in the test, my value is p0. When I do a confidence interval, I don't have the assumption that p is equal to 1/2. That means that I need to use 0.59. My p hat is my best estimate.